looking at anything. Stop, weirdo. All right. Thanks. All right. Researchers designed a study, sorry, a survey, no, to compare the proportions of children who come to school without eating breakfast in low-income elementary schools. An SRS of 80 students from school one found that 19 had not eaten breakfast. At school two, an SRS of 150 students included 26 who had not eaten breakfast or who, yeah. More than 1,500 students attend each school. Do these data give convincing evidence of a difference in the population proportion? So all we're going to do is state hypotheses for a significance test to answer the question and define any parameters. So it's the same as before, except for we're talking about differences. So what would our null hypothesis be? We're trying to decide if there is a difference. So what would the null be? There's not a difference, so it'd be 0. So P1 minus P2 equals 0. And remember, this is no difference. So then what would your alternative be? Just not equal. And depending on whether it's negative or positive, we'll show you which way it's in favor of, okay? So if P1 is higher, it's going to give you a positive number. And if P2 is higher, it'll give you a negative number. So whatever they choose. All right, so what does P1 stand for? What? Yeah, we're missing one. One more time. What does P1 stand for? Okay, the true proportion of what? Children where? What school? Yeah, at school one. Make sure you define which one it is. At school one, what? Good. And then P2 is the same exact thing, except for it's what? School 2. Yep. So just keep going from there. You don't have to rewrite it. That's it. Yes. You want to make sure you write everything out. Everything. All right. So when you're done, flip it over. And we're going to talk about conditions for performing a significance test. Is that a sneeze? Did you just sneeze? Remind me to tell you about that. No, about that cup. All of these are the same as before. I'm not going to make you rewrite it. Okay, they're the same as before. So the same ones that we wrote yesterday. Yesterday we were making a confidence interval. Today we're doing the test to test the p-value and finding, a significance test so that we can find a conclusion. Okay. So yesterday was confidence interval. Today is just doing the significance test. So these are still the same thing. So your random and 10%, you already knew that. Your large counts, remember, is your N1, P1, N1, 1 minus P1, and then N2, P2, N2, all that. Got it? Yes. Yes, you remember, right? Okay, cool. I'm worried. Your two sample z-test for the difference between two proportions. Suppose the conditions are met to test the hypothesis. Your null, that P1 minus P2 equals 0. First, find the pooled proportion of successes. What? Yeah, and you can define whichever one you want to be P1, P2. That's what I said. You have to write it all the way out. Okay. It will always be 0 because there is no difference there. But you can switch it to be P2 minus P1, whatever you define them as and whatever they ask for. As long as you define what these two are and you have it in the correct order, it's okay. Of successes in both samples combined. Then compute the Z statistic. So Z equals P hat 1 minus P hat 2 minus 0. Remember, this 0 comes from the null hypothesis. Okay, so don't wonder where it came from. That's where it came from. So it will always be 0 in this case. And then underneath, we're going to squish this in. P hat combined times 1 minus P hat combined. Over N1 plus the same thing, P hat combined 1 minus P hat combined over N2. So that's where you get this second sample in there. Sorry, I squished it up. Find the p-value by calculating the probability of getting a Z statistic this large or larger. In the direction specified by the alternate hypothesis H sub A. And then how do we find p-values? Remember, and you don't have to write this down. We're going to have Z is less than or equal to whatever your value is. I guess I shouldn't put that there. It's whatever your Z value is. So let's just put an A there. And then we do normal CDF based off of that with mean 0, standard deviation 1. So don't forget that because we're about to do that. Also remember what type of test is showing the difference. What type of test is this? Two-sided. So what are we going to do to the p-value when we find it? I thought y'all didn't remember anything. Just saying. All right. So researchers designed a survey to compare the proportions of children. This is the same exact thing. More than 1,500 students attend each school. Do these data give convincing evidence that the alpha equals 0.05 level of a difference in the population proportion? So this is going to be a state plan do conclude. So what do we put in the state? It's the same thing we always put in there. And we've already done those. P1 minus P2 equals 0. P1 minus P2 does not equal 0, which causes a two-sided test. And we talked about two-sided test means you multiply the p-value by 2. We've already defined P1 and P2. So I'm not going to make you do that again. Know that it's on that other part, but P1 dealt with school 1 and P2 dealt with school 2. And the other thing that we put in here is our alpha level. What goes in the plan part? A 2 sample. 4. Okay. All right. And then our conditions are? Okay. Is it random? Says SRS of 80 and an SRS of 150. So yes. 10%. We have to do both of them. Remember that it said more than 1,500 students attend each school. So as long as this number is less than 1,500, we're good. So school one is good. And then 10 times 150. This is less than or equal to the population. It said more than 1,500. So we said 1,500 on this one. It is okay. All right. And then large counts. Just to remind you, it's N1, P hat 1, N1, 1 minus P hat 1. And I'm going to go ahead and give you those values, 19 and 61. So those work because they're greater than or equal to 10. And then you have to do N2, P hat 2, 1 minus P hat 2. And we get 26 and 124. In just a minute, I'll define P hat 1 and P hat 2 if you don't know where that's coming from. Okay, if you don't know where the proportion is coming from. So in our do part, we're going to do that formula. Z equals P hat 1 minus P hat 2 minus 0 because that's what we want in our null hypothesis, no difference. Square root of P hat combined, 1 minus P hat combined, and I'll talk to you about that in just a second as well, over our first sample. Same on the top, over our second sample. So in the beginning, at school 1, 19 out of 80 had not eaten breakfast. In school 2, 26 out of 150 had not eaten breakfast. And then you're literally going to combine them. So combine them by adding, you're not adding the fractions. Understand that. You're not adding the fractions. You're adding up all of your kids that had not eaten breakfast in all of your sample. Okay, so it's going to look like this. 19 plus 26 had not eaten breakfast out of your samples of 80 and 150. So those are what you're combining. And that will give you 45 out of 230. When you put all that into your calculator or you put it all in, it's complicated, it's crazy. You can write it all out if you want to, but I'm going to go ahead and tell you that it gives you 1.17. This is the crappiest part of it. And I keep them as fractions so it's accurate. It's not a bunch of rounding, okay? And you can do that in your calculator. It's really just time consuming. So there is my Z value. What do I do with it? How do you know which one's lower, which one's upper? I honestly, I always make this statement, and I don't know that you guys do it on your test. Remember that you always want to make a probability statement because that's what we're looking for. So make sure that you start doing that because they're going to be looking for that. And then we either want it greater than or less than 0. It doesn't matter as long as it's not equal to 0. You can pick whichever one, okay? So I'm going to say we want it greater than 0. Does not matter. That just tells you where to put your numbers, okay? Tells you where to put your numbers. Not 0. Sorry, not 0. I'm stuck on that. 1.17. And because it's two-sided, it doesn't matter which one you use. That's why it doesn't matter, okay? Now, if your alternate said greater than, then you use greater than in that statement. If your alternate said less than, use less than in the statement. All right, so then you can do your normal CDF. If it's greater than 1.17, that's going to be your lower. 10,000 is going to be your upper. And then we change it to a Z value. So 0 and 1 are going to be your mean and standard deviation. Make sure you define those. I didn't write it out if you need to. Okay. When you put that in your calculator, you get a value of, I don't have that value. What do you have to do this p-value? So 2 times this number, which I'll tell you gives you 0.2427. That may be off from rounding. Let me check that, make sure. 1.17, 10,000, 1 times 2, 242. They have 0 in the calculator. I didn't like it because I rounded a lot. Everybody good? So this value, just so you know, was 0.1210. This one?
Yeah, it's P naught combined.
Yes.
Okay, I wrote P naught.
Yeah. All right, so then we conclude. That's where we test our p-value against our alpha. Our p-value is 2420. Our alpha is 0.05. Our p-value is greater than. So what does that mean? Thought y'all didn't remember anything. Oh, it's going to happen. It's going to keep happening. Fail to reject H sub O. So what's that mean? We do not have convincing evidence. That there's a difference in the true proportions of students that had not eaten breakfast between school 1 and school 2. Very good. If you wanted to do this on your calculator, you're going to go to stat and tests and a 2-prop z-test. 2-prop z-test. X1 is going to be 19 because that's how many had not eaten breakfast. N1 was out of 80 students that they surveyed. X2 was 26 out of 150. We said not equal to. And we're going to calculate. And it gives you everything you need. There's your Z of 1.17. And then your p-value 0.2426. There's where my 7 came from. You guys see that? So this is a more accurate number because it doesn't round where I rounded in my problem. All right. And then again, we picked not equal to because it was a two-sided. So then you see your p hat 1, your p hat 2, and then there's your p hat combined. So just so you know about everything. Everything's in there. Good? Yes? All right. So again, that gives you your p-value so you can fail to reject H sub O. Okay. If you need that, stat, test, 2-prop z-test. So I showed you how to do the interval yesterday on your calculator. You can also draw to see it. So if I go back into that, that's not what I wanted. 2 prop Z test. And I go to draw instead. Maybe it'll draw it. There it goes. So there's your two-sided test. Okay. So if they ask you to draw it, you can just do that and put it on there. Otherwise, you're just drawing it like normal. So it'll be at 1.17. That's what you're seeing right now, 1.17 and negative 1.17. And it's both sides. Got it? It's pretty simple. You don't need your calculator to draw them. They're really easy. All right. So that's what that technology corner was about. So high levels of cholesterol in the blood are associated with higher risk of heart attacks. Will using a drug to lower blood cholesterol reduce, should say, heart attacks? I thought I fixed that before I gave it to you. The Helsinki Heart Study recruited middle-aged men with high cholesterol but no history of other serious medical problems to investigate this question. The volunteer subjects were assigned at random to one of 2 treatments. 2051 men took the drug gemfibrozil to reduce their cholesterol levels, and a control group of 20-30 men took a placebo. During the next 5 years, 56 men in the group and 84 men in the placebo group had heart attacks. Is this difference significant at the alpha equals 0.01 level? Okay. So we're going to state. What are we going to state? What's our null? Okay, be careful on this alternate. What's our alternative going to be? Why? We want to reduce heart attacks. That's the difference. They didn't just say, is there a difference? They said, we want to reduce it. Okay, so watch that. All right, so what would P1 be?
The truth is proportion of using the drug group
Yeah, taking drug.
that has
And P2 would be the same thing, but placebo that had the heart attack. One more thing that goes in here. Alpha, which is, yep, they changed your alpha on you on this one. What's our plan? A 2 sample Z test for proportions. I think if you do 2 sample Z tests, you'll be fine. Okay. We're going to check our conditions. Is it random? Yes. How is it random?
Which treatment you were assigned.
Random assign treatment. Good job. Be careful on this 10%. Be careful on this 10%.
Do you multiply by the amount of people that have heart attacks?
Do you? What's the difference in this one? What's throwing you off on this one?
Because there's the number of people.
Would you just do that
Oh, no.
What's different about this compared to anything we've been doing? Read it one more time. Tell me if anything kind of throws you for a loop. What was the random to? The treatments. What's 10% do with? Okay,
It's, negative independent.
but what, you said it deals with a sample, right? Did they take a sample? What they did?
This is the volunteers that-
Oh, they volunteered, right? They volunteered, right? So they are the population, okay? So in this case, if you don't sample, we didn't sample from the population, we had them volunteer, there's no need to check. Okay, so we haven't had that come up yet, but watch that. So anytime that they volunteer, we don't take a sample. What about large counts? Think about this. Remember, it's the number of successes and the number of fails. So our success, as morbid as it is a person having a heart attack. You got that? So in the first population, how many had a heart attack? Which would leave out of the population 1995. Does everybody understand that? Success and failure. Everybody know where I got 1995 from? Okay. So then what was the success for the second group? 84. And then if we subtract it, we're going to have 1946. All are greater than or equal to 10. So that checks out. Do. What are the things we need to know in that formula? That Z formula. What else? One more thing. P hat combined. N1 and N2, you already have that, but it does not hurt to write it down, especially if you don't write the formula. Okay. So P hat 1 was 56 out of 2051. 84 out of 2030. P hat combined, remember we just add the tops, add the bottoms to get 140 out of 4081. What was N1? 2051, and N2 was 2030. So the formula is P hat 1 minus P hat 2 minus 0 over the big fat square root of P hat combined, 1 minus P hat combined over N1 P hat combined, 1 minus P hat combined over N2. And we'll get negative 2.47. What do I do now? I would go ahead and write my probability. What symbol am I going to use here? Less than, because that alternate says that. Negative 2.47. Then we do normal CDF. What is my lower? What's my upper? And then 0 and 1. So negative 10,000 negative 2.47, 0, and 1. And again, the probability statement helps you write those and know which way it goes. When you put that in, you guys can see you get 0.00675. You could do 6, 8. It doesn't matter. You just need to be able to compare it to alpha. So in your conclusion, your p-value compared to your alpha is greater than, or the p-value is less than. So we reject H sub O, which means that there is a difference, not just a difference, there is a there is
Smaller,
a reduction. Yeah, shouldn't be, right? Everybody got it? All right. Between the placebo and the drug. Okay? Mhm. Mhm. A reduction in heart attacks when using a drug to lower blood cholesterol, or when using gemfibrozil to lower cholesterol. All right, one more page. Same thing, state plan to conclude. To study long-term effects of preschool programs for poor children, researchers designed an experiment. They recruited 123 children who had never attended preschool from low-income families in Michigan. Researchers randomly assigned 62 of the children to attend preschool, paid for by the study budget, and the other 61 to serve as a control group who would not go to preschool. One response variable of interest is the need for social services as adults. Over a 10-year period, 38 children in the preschool group and 49 in the control group have needed social services. Does this study provide evidence that preschool reduces the later need for social services, and justify your answer? All right, what's my state? What's your null hypothesis? Just P1 and P2, right? No hats, because that's the population proportion. P hat means the difference, or the sample proportion is equal to 0, so there's no difference. What about alpha? Sorry, I wouldn't. Sorry, alternative is less than. Why is it less than? Yeah, it does say reduces right there. P1 is what? The true proportion that did attend. And you want to, again, write all that out, but I'm not going to make you do that right now. What is P2? Did not attend. One more thing in here. What's the alpha? Perfect. Gosh, I thought y'all didn't know anything. Y'all will be fine, I promise. Well, some of you will. All right, plan. Two sample Z test. Okay. What else? Say your first one is random. Yes, it's a randomized experiment. What about your 10%? Yeah, they didn't take a sample, did they? What did they do? They just went and got them, right? They went and got them. Yeah, so this one doesn't need to check. And then large counts. What are your numbers? For P1, what was your success?
38.
Okay. So what would your failure be?
And 62 minus 48.
Oh, what is that? Yeah, because that's hard math. I don't know how you'd ever be able to do that. Every one of you have your phone sitting on your desk and they all have calculators. I'm just saying. What about the other one?
49.
Can you do that math in your head?
Yes, that would be 12.
Perfect. All greater than or equal to 10. I know somebody could do some simple math in here. Maybe that's why y'all are not feeling very confident in statistics. I'm just kidding. I'm just kidding. Do. What do we gotta have?
All the lines.
Mhm. And again, you don't have to do that if you write your formula and then just plug it into your formula because that justifies it itself. So p hat 1 minus p hat 2 minus 0 over a big nasty square root of p hat combined.
So we do use P hat now.
Yeah, in your formula, because you're doing the sample proportion. Does that make sense? So this is population proportion. So we don't use the hat. This one is sample. Over N1 plus P hat combined 1 minus P hat combined over N2. What would P hat 1 be?
30 and 60.
Out of what?
62.
62. Yep, preschool kids. P hat 2 is
49.
49 out of 61. P hat combined would be, how would you find it? 38 plus 49 over 62 plus 61. You don't even have to put it together. You don't have to put it together. When you put all of this into your formula, you're going to get negative 2.32. We want the probability that Z is less than negative 2.32. So then we do normal CDF. What's your lower? Upper, mean, and standard deviation, which will give you a p-value of 0.0101. We're going to conclude by comparing our p-value to our alpha, 0.0101, to our alpha, which is 0.05. What would happen? We do what? Why? Yeah, it's less than, so reject. What if it were, the alpha was 0.01? Yeah, we would fail to reject. So that's where those type 1 and type 2 errors come in. All right, so reject H sub O means we have convincing evidence that preschool reduces the later need for social services. Any questions? Everybody good? We're not doing a 10-1 summary. We're going to be done. Everybody good? All right. I have not put up your homework yet. Again, I told you guys that's how it's going to work for this unit because I don't know where I'm going to get to day by day. So I will get that done in the next 5 minutes and I will email you when it's posted. So I'm going to stop sharing, stop recording.